For number 18, we are going to start with f plus g of x, which can be written as f of x plus g of x. And my f of x function is negative x plus 1. I'm going to add that to my g of x function, which is 4x minus 2. And then I'm going to combine like terms to get 3x minus 1. And the domain is the intersection of the domains of f and g. Both f and g have the exact same domain of all real numbers, so that intersection or overlap is all real numbers, negative infinity to infinity. And then f minus g of x is written as, or can be written as, f of x minus g of x. And then I'm going to go ahead and write down my f of x function, which is negative x plus 1. And I'm going to subtract off g of x. And I want to make sure I subtract the entire function. So I'm going to use parentheses when I subtract. And then you're going to have to distribute the negative sign that is in front of those parentheses. So we end up with negative 4x plus 2. And then we combine like terms. I'm going to get negative 5x plus 3. And the domain of f minus g is the same as f plus g. It's the overlap or intersection of the domains of f and g, which is going to be negative infinity to infinity. And then we have f times g of x, which can be written as f of x times g of x. And my f of x function, once again, is negative x plus 1. My g of x, once again, is 4x minus 2. And I'm going to use parentheses in order to show my multiplication between the two functions. And we're going to FOIL that out. So we're going to end up with negative 4x squared. On my outers, I'm going to get positive 2x. On my inners, I'm going to get positive 4x. And the last term in each group, when I multiply them together, I'm going to get minus 2. And then I'm going to write that as negative 4x squared plus 6x minus 2. That's cleaned up, and the domain for f times g of x is the same as f minus g and f plus g of x, which will be the intersection of the domains of f and g, which is negative infinity to infinity. And then we have f times f of x, which is f of x times f of x, if I write it out, expanded. And f of x is negative x plus 1. So you can write that as just being squared, or you can expand that out and write it again, which I like to do because I just can FOIL easier that way. So then I'm going to get x squared, and then minus 1x minus another x, and then plus 1. And when it's all cleaned up, I have x squared minus 2x plus 1. And the domain of f times f of x is going to be the intersection of f and itself, which is negative infinity to infinity. And then we have f divided by g of x, which is f of x, divided by g of x. I'm going to write that with a fraction bar. And then f of x is negative x plus 1, and I'm going to write that over top of g of x, which is 4x minus 2. Now the domain of f divided by g of x is still the overlap of the domains of f and g, which is all real numbers. Both f and g have a domain of all real numbers. However, you need to figure out what makes g of x equal to 0, because now g of x is in the denominator and you cannot have the denominator calculate out to be 0. So let's figure out what makes 4x minus 2 calculate out to 0. So I'm going to set that denominator equal to 0. I get 4x is equal to 2, and then I get x is equal to 1 half. 2 over 4, which reduces to 1 half. And that is actually an x value that you cannot have, that's excluded from the domain. It's what causes your denominator to equal 0 on your new function that you've just created. So the domain of f divided by g of x is the overlap of f and g, which is all real numbers except for when x is a half. That's excluded for the domain. So all real numbers except the 1/2. And that is going to go from negative infinity up to a half, union with 1/2 to infinity. All right, so now we have g divided by f of x, which is going to be g of x over f of x. And my g of x is 4x plus 2, minus 2 I should say, 4x minus 2, and my f of x is negative x plus 1. Once again, we have the domain being the same as f plus g minus g and times g, except you have to exclude what makes the denominator equal to 0. The domain of g over f of x is the intersection of the domains of f and g, excluding what makes your denominator equal to 0. So I'm going to take my denominator, I'm going to set it equal to 0 to figure out that value that makes the denominator equal to 0. And that value is 1, so x cannot equal 1, because if you plug a 1 back in, you get 0 in the denominator. And so the intersection of the domain of f and g is all real numbers, except we're going to take back the 1 out of the domain and exclude it. So our domain goes from negative infinity up to 1, and then from 1 to infinity, everything but that 1.